Hi, in this video I would like to demonstrate how to graph two slightly complicated functions. This example often appears on the task list or in exams in college, so I decided to present its solution. Let's move on the first task, where we need to draw the function defined by the formula f of x equals arcsin of sin x. Here we are dealing with a composite function, which consists of an outer function, the arcsin, and an inner function, the sin. Let's draw both of these functions on the side. I'll start with the sin, and at the same time I will write its domain and range. The arcsin is the inverse function of the sin, so to draw it, we need to focus on the sin segment in the interval from minus p divided by 2 to p divided by 2. When reversing, it is natural that what was the range now becomes the domain, and what was the domain becomes the range. All of this so far is very important for determining the domain and range of the function specified in the task. The only question is how to use all of this information now. In the case of such a function, we will only look at the domain of the inner function. The domain of the outer function does not matter, because it treats the entire expression sin x as an argument. This notation only tells us that the sin must be in the range from minus 1 to 1, and it exactly is, so we don't have to worry about it at all and create more conditions. Ultimately, the domain of our composite function is the set of real numbers. The range of the composition will be taken from the outer function. Alright, we have already reviewed how to draw both of those functions. Let's move on to drawing their composition. When it comes to inverse functions, they can often be simplified with each other. And here this also occurs. But it will not be that simple. The reason is that the domain of the arcsin is the interval from minus pi over 2 to pi over 2. So we will only be able to simplify both functions in this interval. But it's better than nothing, so we will place this on the coordination system. We managed to draw the first piece of the function. Let's move on to the next one. Let it be a segment of the same length as the previous one, located to its right. So it will be the interval from pi over 2 to 3 pi over 2. We now face a problem, because we would like to simplify both functions, but in this interval it's impossible. To achieve this, we will use an auxiliary variable t, and we will limit it to the interval from minus pi over 2 to pi over 2 again. Now we need to add pi to our inequality to get the same constraints as in the case of x. Thanks to this, we can now substitute t plus p into our function. We will also use the reduction formula to get rid of pi. After applying the formula, we get a minus, but according to the oddness of the sign, we can place it in front of the expression. After simplifying the inverse functions, we get minus t, but x is t plus p. After rearranging the letters, we get the equality stating that t equals x minus p. Let's substitute this into our function, and finally we get the final result. The function in the interval from pi divided by 2 to 3 pi divided by 2 is pi minus x. Let's place this on the coordinate system and move on to the next interval. Everything will happen in a very similar way. We will use another auxiliary variable, let it be s, and this time the final result is x minus 2 times pi. This makes the segment we drew identical to the one we started with. This is of course not a coincidence. The function we are drawing is periodic. And the final shape of the function looks as follows. The second example involves drawing a very similar function, constructed in the reverse order. Let's start by listing the domain and range of both functions. We will proceed similarly to the previous example, taking the domain from the inner function and the range from the outer function. In this case, everything simplifies much easier, and we will be able to draw the functions right away. This happens because we are reversing the entire arcsin, when in the previous example we only reversed a fragment of the sign, because that's how we construct arcsins. Okay, so that's the reason we had to do so much work in the previous example and so little in this one. Yeah, and we already have the function drawn, so that's it. That's all which I prepare for today's video. Thanks for your attention and see you next time.